HTTP response status codes tell the client what happened when the server processed the request. They're grouped into 5 categories from informational responses through to server errors. In this video, we'll look at the 200 series successful responses. And while everybody knows 200 OK, there's quite a few more, and some of them are surprisingly obscure. The 200 OK response is the most typical one that web servers and applications send back. It indicates that the response was valid and a valid response is being returned. Sometimes the response could be a file such as an HTML or CSS. Other times it might be data in the form of a JSON object. The content type and content size headers will be included in the response so that the client knows how to process the response. The 201 created is a web application response usually as the result of a post operation where a new object was asked to be created on the server. When the front end would like to create a new item on the server, we'll frequently create the object in JSON format, although other payloads are certainly valid. The usual method associated in REST APIs for creating items is the post method. Once the server creates the items, which probably means storing it into a database, the server would normally respond with a 201 and should contain the location header indicating that if the client would like to verify the object, they could follow that path using a GET operation. There's no guarantee what the application will return in the body. Some applications include the newly created object, others contain nothing but the location. There are many applications that simply return a 200 as well. The 202 accepted is a response code that could be used to process items that take a long time. It indicates that the request has been received by the application, but the completion of the work is not done, which is very different than, say, the 200 OK or the 201 created. Suppose that a large report needs to be generated that will take multiple minutes, but you don't want the browser hanging. The server could issue a 202 accepted after validating the request. The contents of the message, however, is implementation specific, meaning that an application is free to choose what they might put in there. The 203 code is an indication that a proxy server was used between the client and the actual server, and the proxy modified part of the response. The modification could be done for things like content filtering, image optimization, or language modification. It turns out, however, that you're not likely to see one of these response codes on the internet unless you happen to be writing your own proxy server. Normally, requests go through a proxy server without any modification, and response codes from the server appear directly in the client. If the proxy modifies anything, it should be changing the response code to 203 to indicate that there was a response. In practice, however, most proxy servers do not actually modify the response codes. For the demonstration this time, we are looking at the network trace under Chrome's DevTools. We can see that when we visit the HTML server directly, we are seeing the HTML content with the 200 response code. If we ask for the file via a proxy, we see that the proxy has modified the H1 tag and it has changed the response code to 203. I initially tried to use the Apache and Nginx to rewrite the HTML using their built-in proxy stuff, but found in both cases that proxy code just left the code as 200. So for this particular demonstration, I had to write my own proxy. The response code 204 is used when an action returns nothing. Typically, it'd be used for an API when handling either a delete or a put/patch request, because in these cases, it doesn't make any sense to send any response. If there was an error in the request because the item wasn't available or the permissions were not granted, one of the 400 response codes would actually be a lot more sensible. For the demonstration, we can use Postman to send in a delete operation for, say, the annual report, and you'll get back a very simple 204 response with no headers. In reality, though, most programmers probably send back a 200 OK, indicating that the operation was successful. 205 reset content. This is another code that isn't heavily used, but it could be helpful in a single page application. Let's start this one by looking at a sample website to understand the problem. If you are the gate agent for a flight, your task is to run each boarding pass through a computer just as the passenger is about to get onto the jetway. In this case, we have a form with only the reference number that needs to be typed. If the agent mistypes the reference number and the passenger is not found, then we show something, but we leave the original input in the box so that the agent can figure out what they did wrong. If the agent types a reference number and it matches what is expected, then the passenger is given the green light and, importantly, the form is cleared, ready for the next passenger to be typed in. The front end can use the 205 reset content as an indication that they should in fact reset the form. In the animation, we can see the client sending an invalid request and getting back the 200 OK message, which is a bit counterintuitive, but remember, the 200 OK is really the HTTP response, which is, of course, a valid response. If the request item is found, then the 205 tells the browser to clear the form. 206 partial content. To start, let's take a look at what happens when you try to watch an MP4 file directly in the browser. We notice this new code called 206 which is appearing. This is the partial content response, indicating that the browser requested only part of the page and not all of it. When dealing with videos, this makes a lot of sense. If you scrub forward to the end of the video, you don't want to have to download everything, you probably only want the last few bytes. The decision about whether to send the entire response or only part of the response is triggered by the presence of a range header where the byte range is provided. The server responds with a 206 partial content and includes the content range header to indicate what bytes are being sent and how many bytes there are in total. 207 multi-status. The 207 multi-status response code is specifically designed to work with WebDAV in response to a prop find request. When a WebDAV client wants to obtain a list of files and folders to be shown into the GUI, it will generate a prop find request, and the contents of the multi-status response could be used to build up the GUI. For the demonstration this time, I'll use a tool called CyberDuck, and I'll do a refresh of the items in the current directory. In Wireshark, we can see the prop find request followed by the multi-status response. In this case, there are 3 items: the folder itself, the academic catalog, and some Word document. 208 already reported. This response code is only ever found embedded inside a 207 response. It is used to indicate that a binding has been found inside a WebDAV collection. You can think of a binding as being kind of like a symbolic link, where one resource appears twice in a collection of documents with 2 different paths. Although the response code is clearly defined in RFC 5842, I couldn't find any Linux servers that implement the binding operation itself, and even CyberDuck doesn't do a request with a depth set to infinity. The documentation in Mozilla suggests that this code really only exists for servers accessing other WebDAV servers. Unfortunately, to generate this code, I had to write my own WebDAV server, well, parts of it, that at least understood shared items that would detect and report correctly. In our collection, we have specifically made the again folder to be the same as the documents folder, which of course will generate an infinite loop if you ask for a listing to infinity. To demonstrate, I'll create a request directly in my manual web client, but curl will also work. We'll ask for depth at infinity, and we can see that the response contains the again folder that comes back with a 208 already reported. 226 IM used. Okay, the 226 IM used is yet another very obscure and hardly implemented or supported response code. The idea is that we could ask for a resource one time and receive it back, and then ask if there's an updated version, and the server will respond back with only the changes. Here's the animation that describes what happens. The client does a request as normal for, say, message.txt file. The server responds with the actual item, but also includes a version number in the e-tag header. When the client asks again for the resource, it can include an if none match and an AIM tag to indicate that it knows one version already. The server can then send back only the parts of the file that have changed. In this case, only the first line changed, so an ediff is sent back instead of the entire message. From my searching online, no browser actually knows how to do this, but I did find some references suggesting that AIM is used internally by Chromium for its update mechanism.